We're going to go over the notes and examples for section 4.1, triangles and angles. So a triangle is the most basic of our shapes. It is formed by three sides joining three non-collinear points. So our points are known as the vertices. So each one is the vertex of an angle, and the multiple, if that plural, if that is vertices. Our sides are segments, so make sure if you're asked to name a set of sides that you remember that it's the two endpoints with the segment bar over the top. So you need to make sure that you remember the segment bar. So we need to talk about how you name a triangle. So the most common way you're going to see a triangle named is using the symbol. So you'll see the triangle symbol, and then the three vertices, and they can go in any order. So you usually see them in alphabetical order. You can also see them in an order where it spells out a word. So angle AB or triangle ABC and triangle CAB are the exact same triangle. If you're typing up your answer on a document and you cannot find the triangle symbol, then just type out the word triangle and follow it by the vertices. Notice that you are not putting commas in between the vertice point names. With triangles, there are three sides. There are also three interior angles. So inside of the triangle, there's 1, 2, 3 angles. And when we name them, because we're going to add some more things later, I've put identifier numbers in here. So we have angle 1, angle 2, and angle 3. Our exterior angle has to be drawn in by extending the sides of a triangle. So when you go to a vertice, there are two sides, and you pick one and extend it in order to create an exterior angle. So when you go to a vertice, there are two sides, pick one and extend it to create an exterior angle. So you can extend either of the two sides to create an exterior angle. Now, the exterior angle is always going to be adjacent to one of the interior angles. And not only are they going to be adjacent, but they're also going to form a linear pair. So you're going to see that an exterior angle and its adjacent interior angle will form a linear pair. We're also going to be classifying triangles. So there's two sets of classifications. We can classify a triangle using its sides, or we can classify a triangle using its angle measures. So there are three side classifications. The first one is equilateral, and it has exactly three congruent sides. So all three sides will be identified as congruent. Our second one is isosceles. If you want to abbreviate, you need to abbreviate it ISOSC. So make sure that you go that far to abbreviate. And it has at least two congruent sides. So you need to understand exactly what it means to be at least two. In a triangle, that means two is the fewest, and there's maximum number of sides is three. So we could either have two or three congruent sides. And so you'll notice that three congruent sides is used for both our interior or our isosceles and equilateral. So you have to be careful with our equilateral triangles because they are also isosceles. Isosceles triangles also have a little side note here because we have special names for the parts or the sides of a triangle. Our congruent sides in an isosceles triangle are known as the legs. So the congruent sides are known as the legs. That third side is known as the base. So our third side, the one that was not congruent, is known as a base. In an equilateral triangle, you can pick any two sides to be legs and then call the third side the base. So any two sides can be the legs with the third side the base. Any two sides can be legs with the third side as the base. And we can do that all the way around the triangle. If there are no congruent sides, then we call our triangle scalene. So scalene's triangle have a small, medium, and large side. None of them are the same. Our angle classifications. So our first one is equiangular. So it has 3 congruent angles. So when you're marking that, you're going to see that there are the same curve in all 3. And it turns out that all of these angles are going to be 60 degrees. So in an equiangular triangle, all 3 of the angles are exactly the same at 60 degrees. Remember from chapter 1 that an acute angle is between 0 and 90 degrees. So if we have 3 acute angles all in one triangle, then we say it's an acute triangle. So an acute triangle is when all 3 are less than 90 degrees. So since our equiangular has all the angles of 60 degrees, our equiangular triangle is also acute. Since all of those angles are 60 degrees, it would fit the requirement of being between 0 and 90. So our equiangular is also acute. Our next one is the right triangle. Now, right triangles are extra special because we have part names for those as well. Remember that a right angle is 90 degrees. And if we have one of those right angles in our triangle, the triangle is classified as being a right triangle. In a right triangle, we also have legs. But unlike the legs of an isosceles, these are the ones that make the right angle. So our 2 sides that create the right angle are the legs. Our third side, which is the longest of the 3 sides of the triangle, is known as the hypotenuse. So you'll often see that really big word abbreviated HYP. So the 2 sides that make the right angle are the legs, and that longest side, which is across from the right angle, is our hypotenuse. Obtuse angles are greater than 90 and smaller than 180. And if you have one obtuse angle, then you call the whole triangle an obtuse triangle. So if you have one obtuse angle, then you have an obtuse triangle. Our theorems or rules, and this time we get a new rule type. So we've not had this rule type before, but we're going to get what is known as a corollary. A corollary is a rule that is easily proven using the theorem that it relates to. So it's kind of like getting a shortcut for a theorem. So we are going to use the triangle sum theorem a lot during geometry. So this particular theorem is going to be referred to over multiple chapters. So you need to make sure that you pay attention. With the triangle sum theorem, we are going to do a sum. So that's an addition problem. We're going to use the measures of the interior angles. So there are 3 interior angles. And we're going to add those 3 together. And the answer is always going to be 180. So the sum of the 3 interior angles is 180. So if we go ahead from here and look at the corollary, so this corollary that's down here relates back to that theorem. So our corollary relates us back to our triangle sum theorem. And this particular corollary requires that you have a right triangle. So this rule only works if you have a right triangle. And it says that the acute angles of a right triangle are complementary. Remember, our definition of complementary is that the sum is 90 degrees. So just a little reminder that if we took the measure of angle 1 plus the measure of angle 2 plus the 90 and set them equal to 180, when you subtract the 90 away, you get your measure of angle 1 plus the measure of angle 2 equals 90 degrees. So instead of having to subtract away the 90 degrees, we could just start with our complementary calculation. We also have an exterior angle theorem. So remember, in order to get an exterior angle, go to the vertex and extend one of the sides. We're going to have a theorem that tells us how to calculate the measure of the exterior angle. So the exterior angle, we can calculate its measurement. So we can calculate the measure of our exterior angle. And we calculate that measure by getting the sum. So we're going to do an addition problem. And we're going to use the two non-adjacent interior angles. So our non-adjacent are the two interior angles that are not connected to our exterior. So whichever exterior angle we have, we're going to use the two interior angles that are not connected to it. So let's start our examples. So pay attention to which part of the picture we're using and our given information. So we have been given that angle or segment AB is congruent to BC. So we need to make sure that we mark that information. So congruent segments get a hash mark. Also, the upside down capital T is perpendicular. So we go to the intersection and create the right angle. So they intersect to form a right angle. For the first two questions, we're going to use triangle AB or BDC. BDC is just this one smaller section. So for this first problem, we're just going to use this one small triangle. Remember, in a right triangle, that the legs are the two that make the right angle, and the hypotenuse is the longest, and it will be across from the right angle. So the first segment that we're looking at is this segment BC. And when you look at the vertex B and you look at the vertex C, neither of them is the right angle. So we are across from the right angle, and it happens to be the longest side. So this is the hypotenuse. When we look at the segment BD, B is not got a right angle, but D does have a right angle at that intersection. So this segment is used to create part of our right angle. And when we make the right angle, it is a leg. For our next question, we are using the entire triangle. So we're using the whole triangular shape for this one. So this time we're using the whole thing. This is an isosceles triangle because it has two congruent sides, and we use our vocabulary for isosceles. So the legs of an isosceles are the congruent, and our base is the non-congruent. So when we look at our information, the segment from A to C is not identified as being the same as any other side in that triangle. So since AC is not congruent to any of the other sides, it is the base. And for the next one, we're supposed to name the legs. Our legs are the congruent sides. So we're looking for the congruent pieces. We can either look in the picture or back in our given to see that that's the segment with endpoints at A and B. Put your bar over the top. And the segment with endpoints at B and C. Put the bar over the top. So make sure you pay attention to which triangle it is referring to and our names of the parts for that type of triangle. In the next set of questions, we are classifying triangles by angles and by sides. So we're going to have a minimum of 2 classifications. Every triangle is going to have an angle classification, and every triangle is going to have a side classification. And then there's one of these triangles that has more than that. So when we start, we look at our angles. And when we look at the 3 angle measures in this one, they are all greater than 0 and less than 90, and that makes all of those angles acute. Since they are not exactly the same, we just have an acute triangle. When we look at the sides, we have 2 congruent sides. And when you have 2 or more congruent sides, it is isosceles. For the next one, there's only one angle identified, and it's identified by a box. Remember that this is 90 degrees, which is a right angle. And by definition, if we have one right angle, we have a right triangle. And when we look at our sides, there are no congruent sides. So this one is scalene. In our next picture, we look at the angles, and you notice that every angle has this same little curved mark in it. That means that they are all congruent. So we have all angles congruent, which makes it equiangular. If they're all congruent and the sum is 180 divided by 3 equal measures would give us that each one is 60 degrees. And our 60 is between 0 and 90 degrees. So since 60 is between 0 and 90, this is also an acute triangle. We have 3 congruent sides, which makes it equilateral. And since 3 meets the requirement for being at least 2, we also have isosceles triangle. So this triangle is a very special circumstance. When you have a triangle that has all the sides and all the angles marked the same, it ends up with 4 classifications because they are 2 angle classifications and 2 side classifications. Our last one here has one angle that's measured, and this happens to be an angle that is bigger than 90, and it is less than 180, which makes this obtuse. And when we look at the sides, there are no congruent sides. So that makes this scalene. For our next set of questions, we are going to try to figure out whether our situation is always, sometimes, or never true. And we're going to rely on our vocabulary to help us make our decision. So remember that equilateral has 3 congruent sides, and isosceles has 2 or 3 congruent sides. And because the 3 is always going to meet the requirement of being 2 or 3, this situation is always true. However, if we turn that around and we start out with having 2 or 3 congruent sides, and then we see how often it would be 3 congruent sides, since this one has an or here, I could have the 2 or I could have the 3. So it's not going to happen every single time. I'm only sometimes going to have the 3 necessary to make the equilateral triangle. A right triangle has 1 right angle, and it will have 2 acute angles. And an acute triangle will have 3 acute angles. And these 2 situations can never occur in a single triangle. So you can never have 1 right and 2 acutes at the same time as having 3 acute angles. Our third one wants to know how often the exterior angle of a triangle is acute. So let's remember that acute means that it is going to be between 0 degrees and 90 degrees. So there are 4 possible situations. We could have an equilateral, an acute, a right, or an obtuse triangle. And in order to figure out the exterior angle measure, we actually use the fact that we have a linear pair with the adjacent interior angle, and then we use the linear pair postulate, which means that they're going to be supplementary, and that gives us a sum of 180 degrees. So it's a linear pair with our adjacent angle. We use the linear pair postulate to get supplementary, and supplementary means that we're going to have a sum of 180. So 180 minus a 60 makes 120, and this is not acute. 180 minus an acute angle of 30 would be 150, and that is not acute. If you have a right angle, then the angle right beside it is also going to be a right angle. And if we have an obtuse angle like 100, when we subtract, we would get 80, and this 80 meets our requirement for being an acute angle. So our acute angle only happened 1 of the 4 times, so it is a sometimes situation. In the next question, we're going to find the measures of the numbered angles. There happen to be 9 numbered angles in this picture. We're going to use information from our previous chapters as well as our 2 new theorems. So if we start, in chapter 1, we were taught how to recognize vertical angles, and we also got a theorem that says that they are congruent to each other. And we actually have several sets of vertical angles in this picture. So look for the x's for your vertical angles. So this angle 2 and 3 are a set of vertical angles. So this angle 2 and this angle 3 are going to be the same measurement. We also have a set of vertical angles with 4 and 6. So whatever I get for angle 4, I'm going to use the same thing for angle 6 because of vertical angles. And we have one more set of vertical angles. So our last set of vertical angles is over here at the far right side. That angle 8 and this 65 degrees are vertical angles. So our angle 8 is 65 degrees. We also were taught in chapter 1 how to recognize a linear pair. So if we have two angles that form a line, then they're a linear pair. So I have a line formed by angle 2 and this 125 degrees, and I have a line formed by this angle 9 and the 65 degrees. So I can use my linear pair in order to calculate those. So since the angles are supplementary, the sum is 180. So if the sum is 180 and I subtract the known angle, I will get the missing angle. I can do the same thing for 9. The sum is 180. If I subtract the known angle measure, I will get the missing angle. So now we have angle 2. By vertical angles, angle 3 is going to be exactly the same measurement. Our newest information is about our triangles, and we have the triangle sum theorem. There happens to be 3 different triangles in this picture. So we have 3 different triangles. We can use the first triangle to find angle 1. We can use our second triangle to find angle 4, and we can find our third triangle to help us find angle 7. So the triangle sum is 180. So if we start out with the sum and we subtract the 2 known angles, so in the first triangle, we're going to subtract the 50 and our 55 for angle 2, and we end up with 75 degrees. For our second triangle, we're going to start out with the 180. We're going to subtract the 55 for angle 3 and the 85 for that angle at the bottom of that triangle, and we end up getting 40 degrees. Before we move on, we already said that angle 4 and angle 6 were going to be vertical angles. So now that I have angle 4, angle 6 is that same 40 degrees. And now when I go to the third triangle, the triangle sum is 180. We subtract the 40 degrees for angle 6, and we subtract the 65 degrees for angle 8, and we get 75 degrees for angle 7. So there's only one remaining angle in this picture, and that is angle 5. Angle 5 is outside of triangle 2, so we can use our exterior angle theorem. So we can use our exterior angle theorem. We just need to make sure we know exactly what the non-adjacent interior angles are. So if angle 5 is on the right side, we go to the left side of this triangle, and we're going to use those two angles. So we're using angle 3 and 85. So I have to use angle 3 and this 85 degree angle, and I'm going to get their sum. So I'm going to add them together. So I'm going to add the 55 for angle 3 and the 85, and I get 140 degrees. And now we have all 9 of those angle measures. Be careful that you read the entire set of directions for a question to make sure that you actually complete the problem. So our variable expressions represent the angle measures of a triangle. So this means that we're going to use the triangle sum theorem. We're going to then find the measure of each angle. So notice I'm not going to stop once I know the value of x. I'm going to have to calculate the measure of each of those angles. And then once I have the angle measures, I can classify this triangle as being equiangular, acute, right, or obtuse. So let's start with the triangle sum theorem. So there are 1, 2, 3 angles that add together to make 180. The first angle, A, is 2x. So this is my measure of angle A. I'm then going to take the measure of angle B, which is the x, and then my measure of angle C. And I don't have to write in the parentheses. The parentheses are there to tell me that this entire calculation of x minus 20 is the angle measure. And since I'm not doing any multiplication with it, I can drop the parentheses. So we go through the solve process. When we combine like terms, there are 4 x's minus 20 equals 180. We're going to add the 20 to get 4x equals 200. And then we're going to divide by 4 to get the x is equal to 50. Now we're going to substitute in order to find our angle measures. So angle A is 2 times 50 to get 100 degrees. B is just the 50 degrees. And C is our 50 minus 20 to get 30 degrees. Now when we classify our triangle, we look very closely and see that 100 degrees is an obtuse angle. And because we have an obtuse angle, this is an obtuse triangle. So if one of your angles is greater than 90, it's obtuse, and we have an obtuse triangle. If one of the angles is 90, it's right, and you would have a right triangle. And if all of them are less than 90, it's acute. And if all of them are exactly the same, it is also equiangular. So our last example problem is wanting us to find the exterior angle measure. So this one wants us to find the exterior angle measure. Well, our exterior angle measure includes a variable, so we're going to use our exterior angle theorem. So our exterior angle, which is the 3x minus 22, is going to equal the sum, which is addition, and we have to use the non-adjacent interior angles. So let's look at the placement. Our exterior angle is at the bottom of this picture, so our non-adjacent interior angles are going to be those 2 angles at the top of this picture. So when I fill them in, I need to fill in my 2 non-adjacent interior angles. So I need to use the 2 inside angle measures that were not next to my exterior. So we're going to use the 80 and x. We're going to solve for x. So I'm going to subtract the x, and I'm going to add the 22. And this is going to give me 2x equals 102. When I divide, x is going to be 51. And now I need to substitute this value into my calculation. So when I look at this, it's going to be 3 times 51 minus 22. So that's 153 minus 22 to give me 131 degrees. So use these notes and examples as needed to help you with section 4.1. So use these notes and examples as needed in order to do section 4.1.